So now we're going to talk about the most interesting method of them all, which is trySplit. And this is the method that's going to do the heavy lifting to actually break things up into chunks. And this is quite different from the earlier version of things we looked at. And this is the one that's used with the SearchWithParallelSpliterator's class implementation. It's not used with search with sequential streams or search with parallel streams. It's only used with search with parallel splitterators. So, as you saw before, we have this regular expression, and it's going to try to match the number of times things appear in the input string. And now we're going to focus in on the trySplit method. And trySplit uses several helper methods because it's actually very complicated for reasons you'll see in a second. So these are the methods that are used for parallel streams as opposed to sequential streams. All right. Notice as we go through this, there's no synchronization of any kind used in any of these methods. And that's by design. The splitterating process does not occur in multiple threads at the same time. It only ever occurs in one thread. And then the chunks that are split off are then thrown into the fork join pool and stolen by other threads in the pool. So we don't need to worry about any locking. Here's a high-level synopsis of what trySplit is going to do in this case. So it's going to try to split the input evenly so the phrases can be matched in parallel, but it's got to be careful to not split things in a way where the split crosses the phrase boundary. That would be bad. So basically, here's what trySplit's going to do. And keep in mind that you don't have to split entirely evenly in order to be efficient. We're only going to not split evenly if there is a straddling of the phrase, and then we're going to basically do the split so that the phrase shows up entirely in one of the chunks. So here's what it looks like. We're going to start off with this code here. I recommend you read the actual code if you really want to see it. It's very heavily commented, more commented than I'm going to show you comments here because they don't fit on the slides. Lots of comments in the code. The first thing we're going to do is we're going to check to see if the input is too small to be split any further. And if you recall, the constructor for PhraseMatchSpliterator set this field called mmin split size, and it was the original input length divided by 2. And so it's going to set this particular value, and if the size of the input is less than this minimum split size, we're going to return null. And all that says is streams framework now process things sequentially from here using try_advance. So as I mentioned before, it's basically going to split this thing basically 4 times per string. OK, so if it wasn't too big, what we're going to do then is we're going to try and guess the split position. So up here, as you can see, if you look up here, this is, let's assume this is the input. And I'm only focusing, obviously, on a subset of the input. This is the work of Shakespeare, right? And so let's say that we're searching for the phrase, brevity is the soul of wit. And the first thing we're going to do is we're going to take the input, the whole input, its length, and we're going to divide it by 2. And that's going to be our initial guess at where we should try to split things up. You'll see if you look carefully that our initial guess is not a very good guess, but we have to start somewhere. So once we have guessed, then we're going to go ahead and call this method called computeStartPosition with our initial guess at the split position. And that's going to try to figure out where the start needs to be in order to see if we're splitting it across chunks. So we'll look at computeStartPosition in a second. Here's what computeStartPosition does. It's going to identify the position to start determining if a phrase spans the split position. Because what we're doing here is we're trying to make sure we're not splitting things across chunks. So the first thing we do is we figure out how big is the phrase. So we figure out the phrase length. So keep in mind that this is the phrase. Brevity is the soul of wit. So that'll come back with, 18 or however many characters are in that. And then we take the phrase length and we subtract it from our initial split position. And that's going to give us our initial start position, which is right here, if you do the math. And then we do a little sanity checking. We're going to see if this phrase is too long for the input segment. If it is, it obviously isn't going to match, so we're done. Otherwise, we return the computed start position. That's where we're going to start searching to see if the phrase exists at all. And once we figured out the start position, we're going to then call this second helper method called, or I guess it's, yeah, second helper method called try to update split position, giving it the start position, which is this thing, and the split position, which is this thing. And what it's going to do is it's going to update the split position to be something different so that the phrase will not span across chunks. So you can see before, this is the initial split position. And after we call try to update split position, it goes from this to this. So it's going to split after the end of the phrase so we don't end up straddling the chunks, which would be bad because we would never find the search, no matter how hard we tried in parallel. So let's go ahead and take a look at try to update split position. And this takes the start position and the existing split position, and it basically does some really clever computation to figure out if we would have ended up with a split that would have straddled the chunks. So the first thing we do is we figure out what the end position is, and if the end position is greater than the length, so the end position is the split position plus the length of the string. If it's too long, we return -1 because we couldn't, it's not worth looking for it because we'll never find it. If it's big enough, then what we're going to do is we're going to go ahead and call subsequence at the start position to the end position. And once we get this subsequence, we're going to go from here to there. This is the new subsequence, ignoring the fact we haven't split anything yet. This is the subsequence from the start to the end. And then we're going to go ahead and we're going to check this pattern matcher, which is going to match the regular expression, which in this case was brevity is the soul of wit, in this region. And if we find the phrase in this region, then we know we need to adjust the split position because we would have ended up with a phrase that was split across the chunks. So if we find the regular expression there, we're going to recompute the split position to be start position plus the pattern matching start position plus the length of what matched. So either we found a match and we have to readjust the split position, or we didn't find a match and there was no problem in the first place, so we can keep the original split position. In either case, we return the final split position, which has either been updated or not. For this particular case, we updated it, so we would not end up spanning across those boundaries. Okay, now that we've figured out where the split needs to go, we now need to create a new splitterator to handle the left-hand side, and we need to update the right-hand side of the splitterator to only account for the right-hand part, everything from here onwards. Originally, the splitterator covered the whole input region, and now that we figured out the split position, we can make a splitterator for the left-hand part and a splitterator for the right-hand part. So that's what this split input method does. So split input, which is really kind of a factory method, takes the split position, and it then goes ahead and creates a subsequence from 0 to the split position, and that's going to become the left-hand splitterator, LHS. It's going to cover that part of the input. And then we start from the split position to the end of the input, and we update ourselves. Remember, the right-hand splitterator is always the original object updated. We're going to create a new splitterator for the left-hand side here, and then we're going to modify the splitterator for the right-hand side. So we're going to update this. We're going to update the fields in this object to reflect the changes that will now only cover the right-hand portion of the input. So as you can see, we're going to take the right-hand side and we're going to recompute a pattern matcher for that new input that only covers the right-hand side, and that's the new thing that will be used. And then, so we've updated the right-hand side, and then we make a new PhraseMatchSpliterator which covers the left-hand side of this thing. And that will then get passed back. So if you recall the way that trySplit is used by the parallel streams framework with the abstract task method we talked about before, I think it was last time. Remember, it keeps calling trySplit until trySplit returns null. So we'll end up with a bunch of chunks, and then those chunks will be handed off to the fork join pool. And the fork join pool, of course, will start to run those. Threads will steal them, and they'll start to run in parallel. So that's really, really cool. And that's just showing this piece here. So the framework will take all those chunks and throw them into the pool of worker threads, and then those things will run in parallel. And this parallel processing is in addition to the existing parallelism we have for the input strings, the works of Shakespeare, and the phrases, the different phrases from Shakespeare's works. So we've got three things that are running in parallel. The works of Shakespeare as a whole, chunks of the works of Shakespeare as a whole, and phrases. And as we saw before, that had a nice benefit of making things scale up better. Okay, so that's the overview of the trySplit method. I think you'll agree with me that the trySplit method is by far the most complicated piece of code that we've looked at in this whole series of discussions about the search stream